different large denominators. For different large denominators, we're going to use prime factorization. To find the least common denominator, right? That's what LCD means. So any changes to the bottom number, so our denominator, must be reciprocated to the top number. So we have to do the same thing to the top and the bottom. And then to build up to the least common denominator, we will multiply by any missing factor. So it's kind of like what we did in the last video, except it's just going to be larger denominators. So let's look at the first example. So solve for the following. We have 5/16 plus 9/32. Let's go ahead and find the prime factorization of each one. You could do, I like the factor tree. You're welcome to do the divisibility ladder, whichever one you like. So I'm going to go with 16 can be broken down into 2 and 8. 8 can be broken down into 2 and 4, 4, 2, and 2. So it's just 4 2's being multiplied. So 32 can be 2 and 16. Well, then if it's 16, then we know how we can do this, right? We just repeat this. So the only thing that's missing, right? So we have 4. So 1, 2, 3, 4. And so this is the extra one that we need to go ahead and multiply to the 16 to get it to be 32. So we have 5/16. So we need to multiply it by that missing factor. So 2/2 plus then 9/32. So what does that equal? Well, 5 times 2, right, we multiply the top, is 10. 16 times 2 is 32, plus 9/32, so we get 19/32. And as 19 is a prime number, we know we can't reduce this any further, so this is our solution. Let's look at the next example. Example 2, we're going to solve for the following. We have 5/18 minus 3/28. So let's look at 18. That can be broken down into 2 and 9. 9 can be 3 and 3. Then let's look at 28. 2 and 14. 14 can be 2 and then 7. So let's go ahead and look. So we notice we both have 2 and 2. But everything else is different, right? So we have 3, 3 here. And on this one we have 2 and 7. So what we need to do is to the 18 is multiply it by 14, or 2 and 7. We'll multiply it. And then to 28, we're going to have to multiply it by 9, which is the 3 and 3, right? So let's go ahead and start writing this out. So we have 5 and then 18. So we're missing this 2 and this 7, right? Because they share a common 1, 2, but they need to have all of these, right? So in the end, it's going to be 2 times 2 times 3 times 3 times 7. So that's going to be our common denominator. So for this one, right, if we have this and these, then we're missing these two. So let's just go ahead and just say multiplying by 14 on both the top and the bottom. Then we have minus 3/28, and then for this one, right, we're missing, right, if we have this 2, and then we have, right, so if we have 28, we're missing, so we have these 2's and this 7, sorry, and then we're missing the 3 and 3. So that's 9, so let's go ahead and multiply. So let's go ahead, so 14 times 5, 4 times 5 is 20, 5 and then 7. So we get 70, and what's then our denominator? So 8 times 4, 32. This is then 7. Then we have to have a placeholder for 0, and then we move on. And then 8, 1, we add, and then we get 252. Minus then 3 times 9, so that's 27 over 252. So let's see what we get. Right, so let's go over here. So we do 6, that's 10, so that's 3, 4. So we have 43 over 252. And then let's just double check. So if we multiplied 43, say times 6, let's see what this is. 3 times 6 is 18, carry the 1, that's 258. So we can't reduce this, right? 43 cannot be factored out on the top and the bottom. So then this is our reduced fraction.